Hello, everybody. Now we get some very interesting interview with our guest to artificial intelligence. Now we have to invite our guest now. It's Professor Dimitri Coelho Mollo, which are working at assistant professor at Umeå Sweden University of philosophy of science, or also philosophy of artificial intelligence. And he gets some interesting input for our discussion about how intelligent is artificial intelligence. I think we have to talk about it. And now we get some also guest, it's Yervant Kulbashian. I've met before on the internet, and we get some also very interesting topics about artificial intelligence, and we've met sometimes and talking about it also very philosophical. And now I've invited him because he's also an expert on these topics, and I think he's had a better English than I have. So it's perhaps a little bit more comfortable to have a conversation between us. And now, Axel, you're also, yeah.
I try to do my best with my English, yes.
Yeah, I'm trying also with my English. It's an English for runways. Okay. We start our interview, and I have a question before. Dear Dimitri, you are assistant professor for philosophy of artificial intelligence. In this context, you deal a lot with the functional and the effects of AI applications on individual, on society. ChatGPT is on everyone's lips now, and at the moment, could you have imagined doing the interview with a machine instead of with us? What possible changes and effects do you see coming for individuals and society in this context?
Right, so hello everyone, and thanks Dirk and Axel for the invitation, and also Yervant for joining us for the discussion. So yes, I'm a philosopher of science, specialized in philosophy of AI and cognitive science. That's what I've been working on for the past several years. What regards your question, I think it will be definitely possible to have an interview carried out by ChatGPT, provided that you give the right prompt, right? So that you prompt it correctly with the information that you think might be relevant about me and my expertise and your own interests, right? If you do that, then I think it would be possible that ChatGPT could get, good questions to ask. However, it's very likely, I think, that those questions will be somewhat bland or not particularly intriguing questions, right? So they would be somewhat obvious / natural questions that one would ask of someone or from someone who works on philosophy of artificial intelligence, I think. So I think that would be possible, but maybe not super interesting. I think that a human interviewer is probably going to be able to come up with better questions, or questions that are more intriguing or less, obvious, and interact in ways that are more interesting as well. Right, also because we are talking about hopefully about a human audience for this video, right? So we know better so far, at least, how to cater to the interests of the specific audiences that we have in mind, better than these systems can do.
Sometimes I get some guess that ChatGPT only takes some mirroring from the speaker. I don't think that he's really taken conversation. It's more he's just suggests what the speaker wants to hear. I sometimes
right. So that's a worry, right? It depends a little bit on how you prompt it, right? So you may prompt it in ways that make it be less generous with the person it is, interacting with. So I just did air quotes there. I won't do more air quotes, but every time I say that ChatGPT or similar systems converse or believe or anything of the sort, imagine me doing scare quotes all the time, air quotes, because of course it's very problematic to ascribe these human cognitive capacities to the systems, right? We do it somewhat metaphorically so far. So just, for terminological clarity. But I don't think the ChatGPT and these more other advanced systems are just doing mirroring. They are doing something much more complex than that. But one thing that can be a result, especially if you are prompting it without too many details, is that, as I mentioned earlier, it's going to be rather bland. It's going to be a source of it's going to be uninteresting. It's going to be obvious, but just because it's going to choose questions or ways of speaking or writing that are somewhat average, somewhat not dumb but not super interesting either, right? It's going to be something midway. But what it's doing is much more complicated than just mirroring, right? It is taking what the user is inputting, and then what answers it gets, and then it's transforming this in complicated ways within its internal processing, and then producing an output that is often novel, at least in one sense of novel, right? So it's not just copying things that are out there, at least in most cases, or well, in many cases. Sometimes, I mean, we do have some evidence to think that in some cases it's a matter of memorization going on of existing information in the data set. But in many cases we know that cannot be the case, since we are testing it with things that cannot have been in the data set that it was trained with. So yeah, it's doing much more interesting things than Eliza, the old Weissenbaum chatbot, which was actually just mostly mirroring the person interacting with it. But these systems are doing something much more interesting and much more complicated.
You mentioned that what it would say was bland. You also mentioned that the difference is that we might know our audience's interest. Is that the only difference that makes something bland, in your opinion? Or
no, not really.
Is there something else?
Right. So I think, you can, depending on how you prompt it, you can have it not be so bland. But in my limited experience with it and other similar large language models, I think there is, since the system, so there are several reasons, I think. So let me organize my thoughts in a different way. So one is that it is drawing on a data set that is very diverse, right? So in this data set, you're going to find very different tones, very different ways of speaking. And what the system may end up doing is finding a sort of average of all of those, right? And when you do that, you actually expect that the average is going to be some sort of bland output, right? So if you're averaging very different ways of, writing, different tones, and so on and so forth. I'm not saying that what it's doing is averaging, but it's trying to capture, general patterns in this huge data set. And one way of doing that is by trying to occupy the center, so to speak, of the possible space, right? Another reason behind this blandness, I think, has to do with the specific training, especially the ChatGPT and other more recent systems like Claude by Anthropic, for example, also go through, which is reinforcement learning through human feedback. And there, so basically, very, very basically, what goes on in these cases is that the outputs of the originally pre-trained network are given to human rankers that then have to rank those outputs in terms typically of to what extent they are helpful, respectful, honest, and so forth. And then these rankings are used to create another neural network that has as its task that of predicting what ranking a human would give to a new output, right? And then the original system is trained using reinforcement learning in interaction with this new rewards model, right? And that makes it so that things that are, as you may have noticed, right? So these systems tend to be very polite. They apologize a lot, right? They are typically also very verbose. So their explanations are typically long, and they always say, well, but keep in mind that I'm just an AI language model, and therefore I have several limitations, etc., right? So it tends to repeat this sort of information all the time, to use a certain kind of register, right? So it tends to be rather polite and using words that are not particularly aggressive, right? At least if you don't manage, to prompt in a way that goes against those directives of being, polite and helpful, etc., etc. So I think that contributes a lot to the blandness, right? It's a sort of blandness by design, in order to avoid the risk of outputs that are perhaps problematic or harmful in many ways. I think by means of this training, these networks end up being very cautious, right? Which also leads to this sort of blandness in language and this repetition of caveats all the time, and at this point already famous way of saying, as an AI language model, I cannot, blah blah blah. So these are all things that come both from the way the systems are trained, but pre-trained with the data sets they have and how they're trying to produce outputs in light of these very diverse data sets, but especially I think from this reinforcement learning from human feedback. So these are the grounds I think for the blandness, but there are ways around it, right? So if you prompt it right, then you might be able to get much more interesting and in some cases even harmful answers that in some ways trick the system out of that training that it got. But I don't know, I mean, my experience with the systems has been of, well, this is cool for the first 3-4 exchanges, and then it becomes boring very quickly because it's very verbose, very long answers, very repetitive answers, lots of apologizing. And then, of course, the information itself is typically not reliable, or you shouldn't rely blindly on it. So you have to double check everything. So So yeah, my experience has been mostly boredom when interacting with the systems. I mean, I'm very interested, from a theoretical point of view about what is going on there, but when it came to actually interact with them, then I'm not so interested.
Okay, Axel, you get some question? Oh.
Yeah, I wanted to ask if we think maybe about the next level of ChatGPT or whatever, and we see now that it doesn't have these human abilities like spontaneity and what we're just talking about, some kind of little boring. And do you think that these abilities, for example, spontaneity, in the next level will be reproduced by these systems? So the next level can do a simulation of spontaneity, for example?
Right. So interesting question. So one thing is that spontaneity is rather unclear and vague, right, as a term. I mean, one thing to keep in mind is that systems like ChatGPT and these other, large language models that work as assistants nowadays, they are trained in a way that makes it so that they are following instructions, right? So they go through a fine-tuning phase in which they are trained to follow instructions, right, and to respond to instructions. So in a sense, they are trained not to come up with, things to do by themselves, right? They are always reactive, right? So they are reacting to the prompts, the inputs from the user, right? But when it comes, if you mean spontaneity in the sense of, generating output that is perhaps surprising to us, or, intriguing or seemingly creative, I think the systems are already able to do that, right? So if you give them a somewhat surprising prompt, like, write a poem in the style of a 2-year-old or something, they are going to come up with something very interesting, or, at least for our eyes, something that, you might not have expected, or you might be surprised by. So if your understanding of spontaneity has something to do with something that we didn't expect or might not have expected, then I think the systems already have that, right? But when it comes to taking their own initiative and so on and so forth, they don't. But that's not the point, right? So that's not why they exist. That's not what they are for. So that's why they don't do it, right? Or partly why they don't do it. But even in humans, right? So it's very difficult to figure out, well, what is really spontaneity in humans? What is going on there, right? So how do we understand that in our, social interactions? So what makes a person more spontaneous than another? It's all very, tricky, to really understand or really characterize carefully and clearly.
One example I once tried was to get it to come up with a crazy idea of a story. Write a crazy, I literally said the word crazy story, and he wrote a crazy story, then asked for even crazier. And it wrote mostly the same story with one or few changes, and then asked for even crazier, and it just reached a plateau of craziness. So
right. Perhaps we don't know our own plateau there, but it's probably higher.
How much is the level of craziness of artificial intelligence?
Right. But in these cases, I think, the constraints posed by, filters and by reinforcement learning through human feedback also cap, because you might think, or that, as you ask more and more of it in terms of, coming up with something crazier and crazier in terms of plots, it may, hit the limits of, what it has been trained to take as safe.
I get also a crazy idea. I think the mental healthiness of artificial intelligence would be a great litmus test of consciousness, because when the machine gets a little bit mental illness, they have to get some brain insight or something like consciousness, perhaps.
Right, but even that is tricky, right? So especially with some recent, I mean, not so recent at this point, but some months ago, there were some reports, people beta testing the systems, in which those systems seem to be engaging in something that, if it were a human doing that, we might think that there is some disorder going on, right? Some sort of obsessive-like behavior and stuff like that. So all these things are quite, I mean, partially they are quite easy to emulate, but it's also quite easy to convince us that something is doing more than it is, especially when it comes to things like intelligence and cognition, right? So we know that we have a tendency to ascribe anthropomorphic properties, even to things that we know very well how they work and that they are not anthropomorphic, right? So we may treat your car as if it were a person, for example, or especially your computer, right? You may embed it every now and then, and threaten it if it doesn't do what you want, and things like that, or compliment it when it does its job very well. But of course, it's not a person, and couldn't care less about anything, neither your screaming nor your compliments. So I think from one side, those things, superficial behavior or superficial human-like behavior is quite easy to reproduce or to, emulate. And on the other side, we are very gullible to these kinds of things. So I'm always think that we have to be extremely careful when, extending or ascribing human-like capacities and properties to such systems, right? For both those reasons.
Yeah. So the Turing test is a wrong test designed to get achieve of the intelligence of a machine. It's proved by ChatGPT that it's wrong, or could I say so?
Right. So the situation there is complicated because the Turing test wasn't really meant by Turing to be the source of test for a yes or no, right? It's for intelligence, right? He explicitly says that he's replacing the question, can machines think, with the question, which he thinks is intractable or was intractable at his time at least, with this more tractable, pragmatic question, can they fool a human, right, in a conversation? So, so I think the Turing test has been exaggerated in its importance, even in light of the intentions that Turing had about it. And it might not, for the reasons that I was mentioning, it might not be difficult to, or not too difficult to pass without actually being intelligent in any meaningful sense. I'm less convinced that things like ChatGPT and so pass sufficiently strict Turing test. If you give time to the human, the human might be able to tell, I think, in many cases. And not only because, of course, there are telltale signs that were programmed in through, various different forms of training, like the phrase as an AI language model, right? But there are also other telltales, like the repetitiveness or the tendency to be sorry all the time and not stand your ground. So there are, all sorts of things that a smart enough human could ask the systems that I think would make them detectable as non-human systems. But even if they did pass, well, because just to backtrack a little bit, because that's one of the issues with the Turing test, right? Because as I mentioned earlier, a lot depends on the human doing the judgment, right? So what human are we talking about, right? Are we talking about an AI-informed human who'd know what to look for? Are we looking, or are we talking about, the first person walking around the street, right? That may not be super informed about AI systems, how they work, and so on and so forth. So, it depends. Turing had in mind, just ordinary people being fooled by the systems as the kind of telltale. But I think it's still unclear, because the Turing test in itself is rather vague and unclear itself. But anyways, I don't think it is a particularly interesting question, really, to ask whether a human would be fooled by a certain system, right? I think it tells more about us humans than it tells about the system that we are supposed to be testing. So I do not like the oversized importance that has been given to the Turing test in the whole debate about artificial intelligence. I think it shouldn't have this role.
Maybe that can lead actually into the next question, because we're talking about the difference between appearance and internal structure, or something that we could call internal structure. One of the debates that has been going on maybe since the beginning of AI is the difference between connectionist versus symbolicist type models. Symbolicist saying that it needs to have some kind of structure internally that models the world or something along those lines. It can be very broadly taken. Whereas connectionists just say all it needs to do is make a prediction of the next thing in a very non-structured sort of way. How do you feel that ChatGPT or other large language models have contributed to this argument of internal model versus just make predictions, and even if they're inconsistent, that's fine because humans are inconsistent or something like that?
Right. No, that's a great question. And it's definitely something that is being discussed a lot, also nowadays. You know, so there is a source of there is this large debate, the one that you were mentioning in the 80s, between people like Jerry Fodor, Yervant Kulbashian, and Paul Smolensky about this, right? About do we need a classical computational system in order to do, you know, all the fancy things that intelligent beings do, or is a connectionist system, a connectionist architecture, so an artificial neural network like architecture, enough for that, right? Now, I do think that to some extent, current developments seem to suggest that the classical computationists were wrong in terms of claiming that some things were just impossible for an artificial neural network to do, like, you know, dealing with compositionality in language, for example. So things that were taken to be impossible or argued by these classical computationalists to be impossible for connection systems turned out to be possible, at least at the level of performance, right? Now, for what regards the internal model versus no model, I don't think that's the best way of phrasing the debate there, right? Because so the basic task that large language models are trained to succeed at are indeed just predicting the next token, right, in a sequence. However, the question is not so much what their task is, but how they achieve it, right? So you may think, well, one way to be very good at predicting what the next token is to have a model of semantics, for example, of the semantics of language, right? Or even a model about relationships between physical things in the world, or between, you know, capital cities and the countries they are capitals of, and things like that. So you may end up building a sort of, you know, model of semantics that helps you solve the next token prediction task, right? So you may end up building such a model. I think that the interesting question, though, is where, and the question that also exercised philosophers from you know, the modern age, you know, empiricists versus rationalists, was the question of how much of all of this can be just learned from experience, and how much must be built in from the get-go in the system, right? And what connectionism, and especially, you know, this third wave of connectionism that we're living through, suggest is that much more can be learned by pure experience, right? But just learning from data than we might have thought, right? Now, what exactly is learned is still an open question, right? But it might be, and it's likely, I think, that some models have been learned. So they are models that do not have the features that classical computationists typically posited. So discrete representations that can be, you know, combined in an atomic way. Probably that's not how these models are built, right? But they may approximate these models. So one, I think, very interesting source of, well, not lesson, but one interesting part of the whole discussion in the 80s was this view by Paul Smolensky, saying basically that what neural networks can do is they can approximate all of those things that classical computationalists want. So discreteness, compositionality, and so on and so forth, right? So big enough, well-trained enough artificial neural network can approximate all of those properties such that the performance, the behavior becomes pretty much the same. So I think that might be what we are seeing nowadays, that these neural networks are approximating lots of the properties that classical computational systems might have, right? So but not fully. So representations that are discrete enough, or that can be discretized when needed by the task, rather than having these neat symbols just stored there. But this is, I think, a very interesting open question, right? So to what extent are they really approximating classical computationalist systems? And to what extent, to solve at least some tasks like linguistic tasks, and to what extent they are going in a different direction to solve that task, those sorts of tasks, right? My bet is the former, but I think we should be open to the latter also being possible.
Could be another third way, perhaps, because you've mentioned before the dualism between symbolism and cognition. I think it's some kind of a repeat of philosophy of science that is also similar to the question mind or body. It's and at this point we were always discussing about the correlates, the neural correlates of consciousness, perhaps in philosophy of mind. I think in AI it repeats also this dualism, that we always want to get some things together which we are diverged before. And do you think there are perhaps a third way to get it to combined in a process, not in an entity metaphysical way, more in a process way? It's perhaps a suggestion to get this gap filled.
So one thing that makes me very interested in AI, and has always done so, is that AI sort of, right, is often allows philosophers to test their theories, right? So I mentioned earlier empiricism versus nativism, right? So that's something that artificial neural networks, have a direct bearing on. So some things that people might think are not possible without some innate structures might turn out to be possible, right? We can see empirically that they are possible without rich innate structures, right? Because artificial neural networks are able to do them, to solve those tasks without having those rich internal structures. For what regards the dualisms between mind and body and so forth, that's also, I think, something very interesting, right? So we have basically no philosopher, or very few philosophers, are real dualists, right? Everyone agrees that, mind is matter. Not everyone, but almost everyone agrees that mind is realized by matter, or is just identical to certain arrangements of matter, especially the brain. But the discussion tends to be more about, is it just the brain? Is it the brain and the body? Or the brain, the body, and the environment that all together, make cognition and intelligence arise? And this question is also a question that can be, I think, usefully investigated by looking at AI applications, right? So, for example, there is a large debate now, and a debate which I have been participating in, about to what extent large language models are grounded in the world, right? So when they produce outputs that look like words, right, are they really words? Do they really mean anything? Or is it just us interpreting them as meaning something when what's going on has nothing to do with meaning at all, right? One idea is that in order to be grounded in the world, you have to have a body that interacts with that world. You have to have needs and goals. You have to have interests in that world, right? And only that way can your linguistic outputs be about things in the world, be grounded in the world, right? So that's one view, which is a more embodied view, right? About grounding, or about, you know, how our language gets to be meaningful, right? To be about things out there. Another theory is that that's not needed, that you can get, you know, language be grounded without having a body, right? By sorts of indirect data about the world, which is the case for our existing large language models, right? So they learn from data that was produced by agents who do interact directly with the world, right? And how the world is also helps, you know, constrain the shape that our language takes. It constrains the patterns, the statistical patterns in our language as well, right? So all these things depend on how the world is, because we use language mostly to talk about the world. Okay? So is that enough for grounding? So a system like a large language model that has no direct access to the world, has no body, right? Only has access to text. Is it able? So it's, if you wish, a pure mind, if you wish, right? So by, you know, pushing the metaphor here, but so that you get my meaning. Is that enough, you know, to produce meaningful language? I have argued that it is, that you don't need a body for that. But that's a question that AI developments help us both clarify and try and solve. Right? So, so I do think that AI helps with that as well. So how much of cognition may require a body interacting with the world in real time? How much of it may not require that? Right? So my own view is that some things are going to require a body, needs, goals, interests in, you know, one's own well-being, and so on and so forth, while others might not. Other more simple cognitive capacities might not. And I think AI gives us a nice playground, you know, as philosophers and, you know, theorists of cognition in general, to try these ideas out and see what you know, is more plausible given the evidence that we get from these developments. So yeah, I mean, I think AI is a great test ground for lots of you know, philosophical ideas, including the question of how much of cognition is embodied, how much of it is not, if any, right? So perhaps all of cognition is embodied. I think very few people claim that none of cognition is embodied, right? It's clear that the body plays a role in shaping our cognition, but the question is whether the body itself is part of cognition rather than just shaping or informing the cognitive structures that we have. I tend to think that the body helps shape and inform, but is not itself part of cognition, and the same goes for the environment. But it's an open and very live debate nowadays. So there are reasons to go one way and reasons to go a different way. But AI can help us, I think, bring some clarity to this.
It almost sounds like what you're saying is that AI can help us bring clarity because it can concretize our very general theories into something more pragmatic, and therefore we can get a reflection back. That's my interpretation. Is this like a, because our theories are very general and tend to be very over general, maybe. I don't know.
Right. So that's definitely part of it. But even if you have a very, you know, detailed theory about, you may have a detailed theory about which specific structures are innate in humans, say, right? And some people do have such theories in developmental. And the thing is that, and I suppose that you defend that view not only by evidence from, developmental psychology experiments, but also by the argumentation that say it would be impossible for a system to learn that specific skill without having had an innate structure there in place, right? If you do that, so that line of argument can be pressured depending on, empirical findings that we make with AI systems, right? So it may be that in humans, that's the way it goes, right? So that we have, let's suppose, this innate structure. But the argument doesn't work as an in-principle argument if there is another way of achieving that same skill without that innate structure, right? So what AI systems help us, solve are these kinds of argumentative moves, right? So, which again, going back, to that old debate in the 80s, which is not that old anymore, as we found out in the past years. So is compositionality something possible for connectionist systems? And the claim then was, no, because of these and these reasons, it's not possible, right? Because they don't have discrete atomic symbols, et cetera, et cetera. Now we have connectionist systems that seem to be able, at least to a large extent, to be compositional and to solve compositionality tasks, right? So that in principle argument seems to have been defeated, right? So that's the kind of role I see for AI. Because one thing that I think is also important to think about is that, the way in which AI systems solve tasks might be very different from the ways in which we solve tasks. So, from a theoretician point of view, AI systems also open up, so to speak, a view or an overview of the varieties of possible cognitive systems that might exist, right? So we already have some variety in the biological world, right? So lots of people, for example, talk a lot about octopuses, right? So they have brains that are very different from ours. They are much more diffused throughout the body, right? So they have lots of neurons in their arms as well. They have a body that is extremely flexible, right? You can take pretty much any shape. Lives in a very different habitat, but it seems to be very intelligent in its own way, right? And I think AI systems expand this even further, this space of possible systems or possible ways of being intelligent or solving cognitive tasks. So I don't think we should, automatically, when an AI system solves a task, we shouldn't immediately say, well, so it's doing something that is similar to what we do. No, perhaps it's solving that same task in a way that's quite different, right? So besides this, testing our theories or testing some of our arguments and seeing whether they really, correspond to how things are, AI systems also, I think, help us expand our ideas about what cognition and intelligence can be, in systems that are very different from any biological system, right? They have not been, they have not undergone natural selection. They do not have, goals such as to reproduce or even to survive, right? So I think that those features may make it so that the varieties of cognition and intelligence that we might get from AI systems can differ quite a bit from the ones we are familiar with, and even from the ones that we're not so familiar with in the biological world.
Heard some flavor of anthropocentric perspectivism in it. Is it perhaps right when we take always our view of things and put it on other things. As an analogy, you've write an essay about computation and the wrong use of the notion, because we take always the functionalism or the computationalism from Fodor or some kinds of guys which take the analogy to our brain with the computation, and you say that it's wrong. It's our anthropocentric view of it. Is it right, or I'm on the wrong way to interpret it?
Right. No. I think computation is very useful as a way of conceptualizing what cognition does, or how cognition works, and how the brain works, and of course how artificial neural networks work. That's obvious. So I'm not against computation. Computation is more functionalism. I think they are very useful, and I think they may be largely right. However, I am, cautious when it comes to, or I think we should be cautious when it comes to using categories that we use to describe ourselves, or that we use to explain our cognition, for example, in cognitive psychology, and just expand them and apply them to artificial systems, right? I think we need to know a lot before we make such ascriptions, right? So lots of people talk about, for example, ChatGPT knowing things, right? But does it really know anything, right? So knowledge is a term that is, quite strict in our, use between humans, right? It requires justification, for example, on many accounts. And can ChatGPT be justified in believing something, for example, right? It's unclear. Does it believe anything? I don't think it does, right? So talking about knowledge and ascribing the concept of knowledge to these systems is itself problematic, is an anthropomorphization of the systems. And the same goes when we talk about the systems reasoning, for example, right? So we are using human categories and just applying them automatically as it were to these systems, just because their performance is the performance that we achieve by means of knowing things and reasoning about things, right? But we shouldn't do this mapping that quickly, right? As I mentioned, ChatGPT and other large language models, they don't believe anything. So they don't have knowledge in any meaningful sense of the word, right? Of course, we can use this terminology metaphorically, but it's somewhat dangerous, right? Because we may then bring in all the baggage that is tied to the human concept of knowledge and just think that all of that package applies to the AI system, which is very dangerous, right? So if you think that ChatGPT is able to know things, you might rely on its outputs much more, say, right? Or you may think, well, it knows much more than I do, just because it has been trained in this, right? Has learned from all this information on the internet, right? But it doesn't know anything. It doesn't have beliefs. It doesn't have, desires. It doesn't have anything like that. It cannot lie either, right? It's not trying to deceive. It's not trying to do anything, right? It doesn't have intentions, right? So when you use this sort of language, we risk misleading other people and ourselves, right? Because these systems are not human systems. We should not apply these human categories to them in such a, a naive way. So it's both, misleading theoretically, but also dangerous when it comes to the applications and, pragmatics of it.
What point is the difference? Let's talk about knowing, because when I can ask ChatGPT when the year when Einstein was born, 1879, and somebody like me knows it, but what really is the difference? So it's evidently not the fact then that I can reproduce the information, because this is ChatGPT is also able, or better able than we are. But what is the grain or the thing of knowing?
Right. So as it is typically defined in philosophy, it has to do with believing something that is true, that you are justified in believing that it is true. There are counterexamples to this, but it applies to pretty much all cases. So it's justified through belief, to say in a few words, right? So if a system does not believe, then it cannot know. If a system cannot justify or be justified, then it cannot know either, right? So in the case of the output, it's like saying, well, if I have a book, a biography of Einstein, does the book know when Einstein was born? No, of course not, right? It's right, it's produced. You can see the text there saying that Einstein was born in this and this year, but of course you wouldn't say that the book knows when Einstein was born. And the same applies to ChatGPT and other such systems, right? They do not know anything, right? So they have access to information stored in their connections, through training, right? But that's not to know things, right? That's to be able to retrieve information and produce or output that information, right? But that to know is something very different.
Could we reduce the problem to the subject-object term that we have to talk about when we talk about philosophy of AI? If there exists such kind of subject which are talking there, and not an object mechanism, which are always dealing with big data and have no achievement to get what he's talking about. So we're talking about the subject problem.
Right. So I mean, that's another issue, right? There is a sense. I mean, in the important sense, ChatGPT and these other systems, they are not subjects, right? They are not persons. They are systems that do some things, right? But they do not have beliefs, desires. They don't have intentions. They don't have anything like that. They are not liable for anything they say, right? They do not converse. They do not do anything like that, right? We talk about these things metaphorically as if they were doing those things, but they are not, right? They are not capable of doing those things just because they are not the right sort of thing to be able to do those things. And this connects to one thing that bothers me about ChatGPT, but also Bing AI or Claude, is that they refer to themselves as I, right? They say I would think that, so I suggest that you, but there is no I there, right? There is no subject there, right? So there is a system, right, that often is actually sampling from different parts of its huge space, right? But there is no I there. So that's already a source of, misleading way of creating those outputs, right? And sometimes, I mean, my playing with these systems, they say things like, I think that it would be best if you did this rather than that, right? Or my advice would be, but of course it doesn't think anything, right? It cannot give advice, cannot do any of those things. So there is a sort of trade-off, because if these systems were not to use this anthropomorphic language about themselves, it would make communication much more difficult, right? They are already boring in my view. Now, they would be even more boring if they said things like, without using I in their answers, or without saying I think, and things like that, right? They would make communication, or they would make the outputs much less comprehensible to humans. So there is a trade-off there between being honest about what the systems actually are and thus not misleading or potentially misleading the users into thinking that there is an I that is thinking there. And on the other side, you know, allowing or producing outputs that are useful and helpful and easy to understand to humans. So there is a trade-off there. I worry more about misleading the users than I worry about the comfort that those users might have in interacting with such assistants. But I understand that, you know, opinions there might differ. But all of this is very misleading already. So we shouldn't, you know, just buy into this language and think that it is actually, you know, referring to a subject that has thoughts and beliefs and feelings or anything like that.
So would you say that the ability of knowing something depends on the existence of a subject and an object? Did I catch it? Did I understand
right? So
correctly?
Maybe not an object, but definitely a subject that is able to entertain beliefs and so on and so forth. It might be that, well, in the case of, if we are talking about knowledge, we need an object as well, because we need the belief to be true of something, right? So you need both.
I'm not sure if Dirk likes it, but
No. I like it too. But I come now to this question: do we need some Kubernetes seconds order when we wanted artificial consciousness, not artificial intelligence? The machine have to get some environment, perhaps some social environment, perhaps, so to get to this point that he can describe himself as subject. So the embodied AI is perhaps a step towards this kind of future things that machines have an proprioception. Yervant, it's okay.
Proprioception.
Thank you. It's my difficult word, I always that the machines have their own feedback loops with the sensoring mechanism to recognize that there are machines. Perhaps it's the first step.
Right, so maybe not the first step, but it is a step, I think, and not only a step towards consciousness, because you could have feedback systems that are not conscious, right? You can have second order states that are not conscious. But I think it is a step that will be important to increase the capacities of these systems and make them become closer and closer to actually being intelligent systems. I mean, really intelligent systems, right? So just to clarify, I'm not saying that in principle AI systems cannot be intelligent or be subjects or be persons or anything of the sort, right? For now, I'm just talking about what we have now. And I'm saying what we have now, those systems are not persons, they are not subjects, they do not believe things, they do not know things. But I don't think there is anything in principle that would make it impossible for, you know, future AIs to have those features. And one step in that direction might exactly be systems that you know, that have the ability to represent and do, you know, computational processes over their own first order states, and then have third order states that are able to do that on their second order states, and so forth, that are able to interact with the world, that have, you know, goals that do not come from outside, that come from their own needs, say for, you know, energy or leisure or whatnot, right? So goals that are not coming from the user, from an external user, but goals that are, you know, for the sake of the system itself. Then, you know, when we start going that direction, then we start having systems that become more and more similar to actual agents that, you know, we can ascribe beliefs, desires to, and then we can start talking about, you know, really intelligent systems and And for what regards consciousness, I don't know, right? Because consciousness is still a mystery in biological organisms, right? So we don't quite know what it is and how it's produced. So I'm always very cautious when it comes to talking about consciousness because we don't know, right? So when we have very little clue about things, I prefer to wait and see and make progress one step at a time before, worry about this. However, what is clear to me, at least, is that we are very far from anything like conscious machines. The situation we are in of development is very, very far from that. And whether that's possible at all is also an open question to create conscious AI machines, right? And we don't know what we don't know, right? To use that well-known way of speaking.
Do you think it's necessary for us? Now, I'm not holding a position on this one or another, but some people I've heard hold the position that it may not be necessary for us to be aware that they are conscious for them to be conscious, or them to be subjects. In other words, we're basing it on our own knowledge and not on theirs. How do you feel about that?
Yeah, no, I think that's definitely possible. So if you understand consciousness, I think we should understand consciousness in terms of, the what it's like feature of consciousness, right? That there is something it feels like to taste chocolate ice cream, namely deliciousness. And there is something it is like, to look at a beautiful painting or to, enjoy a nice game of squash, say, right? So there is this qualitative aspect to experience that is there, even in cases in which there is no second order state that is aware of that, of the fact that there is such an experience, or there is such a feeling, right? So I think this may, for example, be the case for many non-human animals, right? So they may not have the cognitive sophistication sufficient for having these higher order states, but they still have or might have qualitative experiences. So they may be conscious, even though they are not aware, they don't have a second order state about their conscious states, right? So I think that's definitely possible. It depends a bit on which theory of consciousness you buy into, right? So there are some theories that do require a second order thought, a second order state for something to count as conscious. But anyways, not in the sense of awareness that is involved in introspection, right? So introspection might not be needed at all for something to be conscious. So a system may be conscious without ever being able to introspect on any of its states and experiences and so on and so forth. So I think that's definitely not only possible, but I think extremely plausible. And examples of this, I think, we should expect to be very common across the biological domain.
Do you perhaps mixing or always the terms consciousness and intelligence together? So we're always thinking about intelligence, and then we discussed about consciousness. But perhaps there's the consciousness is more fundamental. It's more a basic biological concept than intelligence. That the intelligence is more the bottom up from this concepts. Is it possible that we that some kinds of bacteria or some kinds of flowers perhaps have consciousness but not intelligence? And now we are constructing always machines with the goal to get to intelligence, but we don't aware of a concept from consciousness, as you mentioned before.
Right, so I think the relationships between consciousness and intelligence are complicated, right? So I think that there can be intelligence without consciousness, and there can be consciousness without intelligence, right? So, I mean, some people do argue that plants and bacteria and so on are intelligent. I don't think they are, but an open question, but I definitely don't think they are conscious, and I think very few people do. And they can be, even like, I don't know, bees. Well, they are conscious and intelligent to some extent, so not the best example. But for example, let's suppose that we come up with, a more general AI system. We might want to say, well, it is intelligent, but it's not conscious, for example, right? And of course, there can be, biological systems that are conscious, that have experiences, but do not have, the source of capacities that are required for intelligence, right? So their behavior might be non-general, for example, non-flexible, but still there may be something it is like to be that particular organism, right? So they may feel pleasure and pain and things like that, even though they don't have the more complex cognitive capacities that we require for intelligence, right? So I think the dissociation goes both ways. You can have consciousness without intelligence, and you can have intelligence without consciousness.
Well, I mean, looking through the questions that we had, maybe we can ask about, this is kind of a deep question, but the logic and social side of things. We haven't really dug into logic much, but do you think that's too long a conversation to have right now? Maybe.
No, I mean, I can say a few things about that, I think. So one thing that has been, I think, historically underlying lots of the ambitions of AI has been indeed to, focus on logical abilities, because those are the abilities that we tend to associate with intelligence. But I think that's a mistake. Logic and intelligence, they are, of course, logic is an important part of intelligence in many cases, at least. But it may not be, necessary for intelligence. So in AI, you have often focus on things like chess playing or Go playing or solving mathematical theorems that we humans from a certain society associate with being intelligent, right? So we tend to view chess players or mathematicians as the, paradigms of intelligent humans, right? And then we try to create AI systems that do exactly that thing that those very intelligent people do, right? But intelligence is much more complicated than that, right? So there is the famous Moravec paradox, that things that are very easy for machines tend to be very difficult for humans, such as, doing complex mathematical operations or, playing chess very well. But things that are just natural to us and that we just take for granted, like just being able to move around a complicated environment, interact with things in a, seamless way, and quickly adapt to different contexts and move differently and think differently. Those things are extremely difficult for AI systems to do. Right? So I think that the focus on logic has a lot to do with our prejudices about what counts as intelligent, what is intelligence and what is not, than with what intelligence actually is. So lots of things we do every day are, extremely intelligent, but they are just so natural to us that we don't bother with them. We don't notice them just because they are second nature to us. And then we focus on these unnatural, weird activities like playing chess, and take that to be the paradigm of what intelligence is, right? But I think that's a mistake, right? I think that intelligence is much broader and much more common as well than just being good at chess or being good at maths and things like that. So I think that focus is misplaced in AI. And I think it may also be, partially behind the fact or underlying the fact that we now have extremely good or excellent chess players, AI chess players and AI Go players, and of course, great software for doing mathematics. But we don't have particularly good robots that are able to interact in a seamless way with changing environments and behave in the real world in sensible ways, right? So this is still an immense challenge. But these are the abilities that we just take for granted, and we don't then consider them to be intelligence just because they are easy to us. But they are actually extremely impressive abilities that are very, very difficult to implement in artificial systems.
We often, the cultural centrism is something that people don't notice. If you think of animist cultures or even tribal cultures these days, who just don't think about logical, like that whole space is not that interesting to them.
Exactly.
We often ignore them as being also intelligent.
Right, exactly. And then there is this whole baggage of the very notion of intelligence that also has, problematic baggage in terms of, excluding certain people that were considered to be inferior or undesirable. So there is also this sort of, bad side to the history of the notion of intelligence that has a lot to do also with what you're saying about, cultural prejudices and how different cultures value differently different kinds of abilities. And so, things that are valued by other cultures may be taken to be less valuable when that culture is a culture that for any reason, for some sort of prejudice, we want to reject, right, or to diminish. So there is also this risk there, right, of building in prejudice into our understanding of what intelligence is or is supposed to be. And it would be terrible, of course, to create AI systems that then we employ all over the world that embody these prejudices, right? That would be horrible.
It was a great pleasure and an honor to get some questions to you.
No, it was my pleasure. Great discussion. I really enjoyed this.
Thank you. We are also too. And thank you very much to Yervant for your also very well questions now.